Alright, hold on guys, I don't have my screen up yet. Okay, who's in the room? Location and test type. And that is the email that you will send your questions to. Happy Friday, everybody. All right, please type in the location you are from and the test type you're preparing for. What's up, Avery? And I know I probably don't do enough for my SIFT people. And so, like I said, I'm going to do some more mechanical and SIFT stuff. All right, send those questions in. So, safe question I'm going to address. We're going to talk about 3 types of main rotor systems. The 3 types. You have the rigid rotor system, and I'm going to put this so if you're preparing for the SIF, you have to be familiarized with the main rotor systems. The first one is the rigid rotor system. It's pretty mechanically simple. The loads are absorbed by bending, so you don't have any hinges in the main rotor, in the rigid rotor system. The semi-rigid rotor system allows for, there's hinges in that particular system, and flapping and feathering is pretty much how that system differs from the rigid rotor system. The semi-rigid rotor system allows flapping and feathering because there's hinges. And I'm going to get actually some model helicopters that I can actually like kind of show. Probably, I don't know, next couple weeks or something like that. Okay. I have a question. It is pertaining to sequences. Now, when you see these, do not freak out. I'm trying to see 2 and 5/6. There we go, that's better. So here's a sequence of numbers. You have 2 and 5/6. The next one is 3.5. One after that is 4 and 1/6. And the last one they give us is 4 and 5/6. Now, these two are pretty close together. So these are the ones. So then you have dot, 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 which means the sequence goes on. So you want to look at how do we get from 2 and 5/6 to 3.5 to 4 and 1/6 to 4 and 5/6. And the answer choices are as follows: 5 and 1/6, 5.5, 5 and 5/6, 6 and 1/6, and finally 5 and 1/4. All right. So 5 and 1/6, 5.5, 5 and 5/6, 6 and 1/6, and 5 1/4. So what I will do is I look at sequence of numbers and I'll say to myself, okay, well, let's see. This seems like the easiest jump. And it looks like we jumped 4 sixths to get to 5 6. So basically, I would break that down. This is actually 2/3. And this was added 2/3. So if I add 2/3 to 5 1/6, put the 4 here, 5/6. And that's if it was added. We don't necessarily know that. But I'm just going to kind of play with this for a moment. 2/3. And if we added it, 15, 12, 18. So 5 times 3 is 15, 6 times 2 is 12, and that will give us 27 over 18. They are both divisible by 3. So we'll break this down to 9 over 6. 3 over 2. Now, that bothers me because 1 1/2, we didn't increase by 1 1/2 to go from 4 1/6 to 5 6. So, maybe. This is not a arithmetic sequence. Hold on, I just got the message. Okay, I had to respond to a message. Sorry, guys. Wow, this is something else. All right, so let's compare because they did not add by 2 1/3. All right, so this is what I'm going to do. I'm going to subtract 3 1/2 from 4 1/6, see what that does for us. So we will get 1 1/2 minus 1 over 6. 6, 2, 12, 4 over 12. 2 over 6. So they definitely did not add. So this is probably a geometric sequence. Okay. And we want the 5th term. All right. So the first term is 2 and 5 over 6 times, I don't know what the common ratio is. This question sucks. So basically, I'm going to do some research on this, Avery, but that is a good question. I can't nail it. What is the 5th term in the series? No, I can't nail it. Wow. Normally it's an arithmetic sequence and they add, but I'll do some research on it and I will present this. This will be the first one I present in next week's. Okay, Maria, you got 5 3/6, but how do you justify that? this is our rigid rotor system. For my Swift guys, that was the rigid rotor system. And then I'm going to present the semi-rigid. Maria, how did you come up with that? That is the question. Okay. So, what is the common ratio? That's what I want to know. I want to know the common ratio. So, did they add? Adding 4/6 or 2/3. Okay. So it was an arithmetic sequence, and 4/6 is the item because I did break it down to 2/3. The 4/6. I broke that down to 2/3. So 4/6, 4 and 5/6 plus 4/6. The 4 is the whole number. When we add 1, this will become 5. And then we will have 3/6. Five and a half. Yep. Because it would be 5 3/6, which would convert to 5 1/2. Okay, so we have the sequence of numbers, and we determined that the common ratio was 4/6. So we added 4/6 to 4 and 5/6, then 5 1/2 is what we wind up with. So the common ratio is 4/6. Complete. All right, Avery got the same answer. That is a hell of a first question. Okay, so send questions in and let's move along. And is everybody clear? Type in clear if you understand it, or if you don't understand it. Let's stop and address that and make sure that you guys understand. If not, I'll look for my clears and we will move forward. And if you object and didn't understand it, we will discuss it, but it looks like everybody got it, so I will move forward. Okay. What I've been getting a lot of emails about is averaging. The question comes in the form of like, okay, you've got temperature readings throughout the day, and you want to find the average temperature. And some people are having problems because they don't realize that it's really like, all right, if I want to take the average of something, say like 2, 5, 7, 3, I would have 1, 2, 3, 4 numbers. So I would add all these up and then divide by the number of numbers in the set of numbers. So 2 plus 5 is 7, 14, 17 is the total, but we're going to divide by 4. So the average, 4, 16, 1, 0 drops down, 2. The average is 4.2. But people are having issues when they have negative numbers. So let's say we took 5 temperature readings. All right. And throughout the day, the temperature readings were -10, -5, 0, 14 degrees, and 22 degrees. Okay. We want to find out the average temperature throughout the day. You're going to add and consider your negative numbers and, deal with them accordingly. All right. So as I add these numbers, I have -15 on the negative side, and then I have 36 on the positive side. So I'll subtract the 15. We get 1, 21. All right. So at this point, we've considered our negative numbers, and we have 5, so we're just going to divide 21 by 5, and it's going to be 4 point something. It's like 4.2. So 4.2 is the average temperature of all these temperature readings. So even if you have negative numbers, you add them like you normally would, and then you divide by the number of numbers in the set. All right, so I've been getting a lot of questions with that. Another one. A question came in actually from an actual test, and congratulations, Caleb, you passed the OAR part of the test. And one question that he had trouble with the mechanical comprehension, the mass of something is not necessarily the weight. All right, so force equals mass times acceleration. All right, so there is a question I always deal with. If we had a scale and they'll ask you a question like, how much does a 50 kilogram object, all right, so on the scale, we put an object on it and it is 50 kilograms. And I'll ask you, how much does a 50 kilogram object weigh? Basically, gravity is in effect because it's weighing this mass down onto the scale. And gravity acts at 9.8 meters per second squared in the metric system, or 32 feet per second squared in the U.S. customary or British units. So typically, most of the times, they're going to ask you what your force is. So what you have to do is compute this in newtons. And Newton's second law of motion, force equals mass times acceleration. The force is in newtons, the mass is in kilograms, and the acceleration is gravity, which is 9.8 meters per second squared. And what else did I want to mention? So we want to know the force that is being applied onto the scale. So it will be your kilograms times 9.8. Now, for rapid math, I mean, you could sit there and you could 9.8 times 50, or I would just 9.8 times 5 and then add the 0. 49. Then add the 0. Add 0, 1 decimal point. Mass 50, acceleration 9.8 meters per second squared. So 490 newtons is the answer. Is how much the object weighs. Now, a good test taking strategy. If the answer choices are spaced far enough apart, I'm just going to multiply by 10, because then that's only going to take me 0.2 off target. So if I had answers like 536, 220, 490, 350 newtons in my answer choices, what I'm going to do is I'm just going to multiply 50 kilograms by 10, not 9.8, because I can mentally do that. And that would have me around the area of 500 newtons if I just did it rough like that. And so the closest answer choice will be there. So you can save a lot of time and move on to the next question after you look at these answer selections. I realized if I go 0.2, I went high, so I overshot. So if I had 500, then I'll be looking for something under 500, which is the 490. So that is a really good test-taking strategy that you can use to save time, because time is of the essence in all these tests. Any questions? Was that clear, guys? All right. So that was one that he didn't get. And let's see. Another thing was lever systems. All right. He saw different classes of levers. First off, we want to be able to establish there's 3 types of levers. And Avery's, yes, one of those dynamite questions while we're at it. You have your first class lever. You have your second class lever. And you have your third class lever. Now, this is the fulcrum or balance point. It's the balance point in the class 1. It is on the end on the class 2 and 3. So we have our effort exerting down. I'll just put EFF. And the load on the other side. The seesaw is the best example of that. This one, the fulcrum, you have the load bearing down here, and your effort is going to be applied. EFF, abbreviating again. And the difference between the second and the third class is that the effort is in the middle and the load is on the outside, or opposite the fulcrum. Okay, so very, very important. Now, in the instance that you get questions like, okay, if we have a 100-pound kid and he is 10 feet away, we have to look at our load moment. Our load moment is the product, meaning multiplication, of the weight times the feet. So we would have 1,000 foot-pounds in this case. In order to get the system to balance out, let's say, okay, well, we're going to put a 50-pound object on this side. And how far do we need to put this out? How many feet do we need to put this out in order for it to balance the system? And my answer, just right off the top of my head, is 20 feet. The fulcrum I look at like an equal sign. So whatever the load moment on this side that's going on, we have to make sure that it goes on this side. And we just get that by looking at the load moment on this side, and you divide by 50. All right, and that will give us 20. And 50 times 20 will yield 1,000 foot-pounds. All right, so yeah, if you normally have two pieces of information on one side of the fulcrum and one missing. In the second class, what you're going to do is you take the distances into account. Let's say this was 2 feet and this was 4 feet. Then in order to get the system to raise the load, then what we have to do is we have to have at least, let's say we have 200 pounds here. Then we have 400 foot-pounds exerting downward. And so we have to have 400 foot-pounds going upward in order to raise the load. So we only need to apply 100 pounds because 100 times 4 will yield the 400 foot-pounds that we need. FT, LBS. The foot-pounds that we need in order to raise the load. And conversely, we do the same thing with the third. The only difference between the second and the third is the effort and the load switches positions. All right. So make sure you're familiar with the classes of levers and how to take into account the load moments. That's like huge in executing these problems. Okay. All right. Okay, good. We got a nice mixture tonight. This one concerns aviation. Kino, please explain to me ground effect. Okay. Ground effect is the interference of the airflow patterns about a wing caused by, flying within one wingspan of the Earth's surface. So let's say we have a wingspan of, 50 feet. Now, if we look at this wing from a side view, it's going to look like that. And you're going to have the air molecules. You're going to have a normal upwash and downwash. Around the airfoil. The airfoil is just a wing or a device that's used to produce lift. Now, above 50 feet, we're going to have this normal upwash and downwash. When we get over the runway, namely, that's when we normally have an issue during hot, humid days. All right, when we get within 50 feet, which is the wingspan, so it varies with your aircraft, we're going to have a reduced upwash and downwash effect because the Earth's surface, up here, the Earth's surface is not interfering above 50 feet. When we get to 50 feet, normally we have 4 forces of flight. We have lift, thrust, drag, and we have the weight of the aircraft. So what happens is when we're landing, we're going to get a reduced amount of drag. We're going to get less drag. We're going to have the same amount of lift. So it will almost feel like there's a cushion of air. It's not a cushion of air. You just have the same amount of lift and reduced drag because the airflow patterns about the wing are being disturbed. And the wing is not flying as if it would above 50 feet. So a couple things that you need to be aware of. Like when I'm coming in for a landing, all right, I need to probably do a little bit of power management. Come in a little bit slower than I normally would, probably, within reason. We don't want to stall. But you'll be very, very as slow as you can get it, like probably like the bottom of the green arc or the bottom of the white arc in the airspeed indicator. Pilots understand what I mean by that. Because if you don't and you have excess speed, then what happens is you'll try to land, and then that cushion of air will keep you floating down the runway, right? And you can't come down. Or you may have speed, and if you can't get down on the first third of the runway, then just go around. Just go around. Because what's going to happen is you might settle down here, and then you won't have enough runway to do your ground roll and braking action. So that could be a big issue. Conversely, taking off, you will become, when you're in ground effect, you can possibly become airborne before your recommended takeoff speed. So the plane will just kind of whoop. But you have to build your airspeed in this 50-foot range. You have to get the proper airspeed to VX or VY, best angle and best rate of climb, and then you climb out. Because if you're not at the proper speed, you get outside of the 50-foot wingspan, and then what happens is this drag comes back, and you don't have the speed, and you don't have the proper lift, and then you could, abruptly settle down very, very hard and possibly damage the aircraft. All right, so the procedure is, in ground effect, you get your nose up, you rotate, you break ground, you get above the runway, you just hover above the runway, so to speak. Build your airspeed, and then climb out. Don't be at a slow speed and then try to climb out, because if you get above 50 feet, in this example, you're going to abruptly settle back down because the drag is going to come back. All right, so I hope that answered the aviation question. That's good. We don't really get a whole lot of them. Strangely, I would imagine I'll be getting more than what we normally get here. Okay, more questions, guys. Send them in. Send them in. Anybody new to the room, I'm Kino from STEMwithKino.com. And basically, I'm here every Friday. If you have military aptitude test questions, ASVAB, AFOQT, ASTB, OAR, SIFT, you can come here to the live stream and get the questions answered that you have trouble answering. I don't know every question in the world. No, I don't always get them all, but with I get most of them. Just being honest there, because some guys will try to act like they're like Albert Einstein or somebody, and I am not. I'm just a pretty decent problem solver. So, there we have it. All right. And Carolyn, is there a Carolyn, California, or you just typed your name and in the state you're from? All right. Here's a really tough distance, rate, and time problem that I was working with the client on today. So we're going to have a little crowd participation with this. And I would like to know from you guys. All right, hold on. Let's take that out. 263. Somebody's car alarm is going off. Alright, faster than efficient mode. Alright, this is the first portion. Nobody type anything because I got to put in the second portion. Okay, okay, now you guys can type in anything you want. Now, I'd like somebody to tell me, is this, because we talk about various types of distance, rate, and time problems, and I have my little labels for them. Basic, expansion, compression, and delayed departure. Somebody type in which distance, rate, and time problem this is. Anybody, don't be shy. What do you think it is? An expansion, a compression, a basic, a delayed departure? Very good, Avery, a delayed departure. It is actually, no. A fishing boat was traveling west for the opposite direction. This is an expansion because the two vehicles or objects are leaving each other. Compression would be them two airplanes flying towards each other for 3,000 miles apart. But this is a really tough one. All right, so good job on that, and let's talk about it. Okay, so line by line. This is how we do word problems. I do this every week. Line by line, line by line. I'm going to beat it into your heads forever and ever and ever and ever. Ever. Forever. Shout out to Outcast. Anyway. All right. So line by line is how we diagram it. A fishing boat left Hawaii traveling west. 0.5 hours before cruise ship. All right. So let's say we have a boat. Don't laugh at my artwork. And then on this end, we have a cruise ship. All right. Now, this guy leaves at 11:30 a.m. And then this guy leaves at lunchtime, noon. All right. So that's the first part. The fishing boat left Hawaii traveling west in that direction. 30 minutes, 0.5 hours is 30 minutes. And I would be remiss. When they give you 0.5 hours, just look at this digit, multiply by 6, and that will give you your minutes. 30 minutes. Okay, so the cruise ship is going in the opposite direction, going 12.5 kilometers per hour faster than the fishing boat for 11 hours, after which time the ships were 322 kilometers apart. So this guy's going here, and the distance information will be given because at the end of it, it will be 322. The rate, the unknown, is X, and the rate here is unknown, but what we do know is that this ship is going 12.5 kilometers per hour faster. So we assign that X plus 12.5. This is just X. It's unknown. And after that time, 322 miles was how much they spread apart. Now, for our newcomers and you haven't dealt with these expansion problems, ooh, that's tight. We're going to have rate times time, and then we're going to add rate times time, and that's going to equal a distance, D-I-S-T. I'm just going to abbreviate that. So what we have to do is we have to look at the rates and the times. Now, they told us for time, 11 hours. All right, so this guy moved 11 hours. This guy moved 11.5 hours because 30 minutes. All right, so we have rates and times. So we have unknown rates and times, I should say. So we have X, which is the rate, times time, which is 11.5, plus rate, and this is X plus 12.5 times time times 11, and that is going to equal to 322. All right, so Just want to make sure. Now, what we need to do is 11 needs to be multiplied by each one of these terms. This will be 11.5x plus 11, because 11 times x is 11, and then 11 times 12.5 is, you guys help me out. No, I'll do it. 12.5 times 11. We'll get 125. 125. 137.5. All right. So the next line, 11.5x, and then 11x plus 137.5 equals 322. So we combine like terms. All right. So 11.5 plus 11, and I want to make sure I'm not running out of real estate here. 22.5x equals the 137.5 is going to jump across the equal sign and become negative. And so we'll have 322.0 because I'm subtracting 137.5. All right, we'll take away from 2, we get 5, take 11, 4, 2, 8. So we have 22.5x is equal to 184.5. And then we divide 22.5 on both sides. And I'm going to do it out by hand. Two, 2.5, 184.5. Now, the decimal out here can't stay there. It's got to go over 1. And the decimal here is going to go over 1 as well. And we'll drop our decimal. Get this guy out of the way. I need a bigger board, guys. And the decimal goes here, and then we raise it up. So we ask ourselves, how many times can 225 go into, can it go into 1? No. Can it go into 18? No. 184? It cannot. And I'm thinking maybe like 8. 2, 2, 225 times 8. Now I'm looking at, for quick math, 8 times 200 is 1,600. And then 8 times 25, 8 quarters would be $2. So 1,800 works. So it's going to be 8 point something. All right, so we get 1,800. 45 comes down, add a 0, drop a 0, 450. Now, 225, if I double 200 and I double the 25, that'll give me the 50. 8.2. So this little guy is going 8.2 kilometers per hour. And if we want to find the ship speed, which is 12.5 faster, 12.5 plus 8.2 is 20.7 kilometers per hour. Now the answer just asked for this guy, but I took the liberty of getting the cruise ship speed as well. Okay, so that was pretty tough. It was an expansion, but we had to pull the information out of the paragraph, line by line. You saw me demonstrate it. This is DVRable, so you can come back later and look at it and watch each and every one of my steps. Okay. Was that clear, guys? Please give me a couple clears so we can move forward. Yeah, it was a long process only because I had to stop and explain it. I probably could have got it done in like 3 minutes without just if I was sitting down taking a test doing it on my own. But when you have to stop and explain things and stuff like that, then it could take up a little bit of time. Somewhat clear. We lost connection. All right, it's DVRable, Carolyn, so you can look at it later. Okay. Wow, that's pretty cool. Actually, this question that you're bringing in, this is a SIFT question. This concerns a helicopter taking off on an inclined plane, which, let's say we had, I don't know, some landscape like this. All right. And the helicopter skids would be pretty much positioned like this. And then we'd have the body or fuselage of the helicopter, and then we have the main rotor up top. And probably 10 times I've seen this question. And it's concerning how you take off. All right. You don't just apply the collective and then boom and come up. You actually need to become level first. So in effect, what you would be doing is you would raise the right rotor, the right main skid first, and then you would take off. You don't just, because if you take off like that, then you'll be at an angle. You'll be tilted already, and you could possibly lose control. So in order to maintain control, you're going to apply collective in your stick, and you're going to actually just raise your skid first, and then you would do your thing and, go on about your business. Okay, not sure what happened there, but I'm back. I was doing the explanation, and then so I'm really not sure if the SIFT guy got that. But again, I'll just recap. The question was, how does a helicopter take off from an inclined plane? You do not just apply your collective and lift off like that. You actually have to raise your right rotor skid. And then your level, I was about to say wings level, but you don't have wings, you're a helicopter. But you get yourself level first, raising the right rotor skid if the helicopter's facing us. And then you do your departure. If you try to just raise the collective like you normally would on level ground, then you're already in a tilted position, and then you're going to actually start drifting, right, immediately. There could be some structure or something like that, obstacles or something like that you do not want to lift to fly into. So you raise the right rotor skid, and then boom, and then you're off to the races. So guys, please hit the like button if you have not hit the like button. What do I want to say? It's like 4 minutes, so I don't see any more questions. If you are a client and you want to come to the Google Hangout, please shoot me an email for the Google Hangout, and we will do some stuff, do some questions. For anybody that's new here, or you just catching a video late or whatever, I'm here every week, Friday, 9 to 10. From 10 to 11, I do a live stream with my clients. And Maria, I think there was some type of issue. I think you fare better if you have a Gmail account and I send it to your email, because I think last week we had some issues. I think you did come in for a little while, but very, very clear for the Google Hangout. If I send it to your Skype, I think it does something funky. Excuse me. It does something funky if I just send it to your Skype. If you're a client of mine and we're connected on Skype, so make sure you send me an email to my email so I can just drag and drop the link, and that makes life easier for me. So again, guys, I'm here every week. If you are taking any military aptitude test prep, any private pilot, instrument pilot, commercial pilot, airline transport pilot, flight instructor, initial, instrument, or multi-engine, and all the aviation ground, I've taken them all. I'm certified in all of them. If you run into questions you don't understand, and just, check in with me every Friday night, 9 to 10. Send questions to my email, and I can address them for you and help you understand things better. So, if you are, again, elegant black tie, I like that. If you are interested in the Google Hangout, please send a message to my Gmail account or email. It's nice when you're actually typing in the box, but it's 9:59 and I start the Google Hangout at 10. There is the email. So send those emails out, and I will see you guys in a little bit. Thanks for watching. I'm Kino with STEMwithKino.com. I'll see you guys next week. Bye-bye. Do my little finger thing. Boop.